Okay, so we're going to be working on 7.1.2 today. Make sure that you've got some paper. There should be some graph paper over by the window. Make sure to pause the video anytime you're getting behind and you need to write things down, anything like that. And make sure to be paying attention. There will be questions as we go along. All right, so in lesson 7.1.1, you looked at single data sets, such as world population. So that's what we were looking at yesterday, these pie charts. Often, you need to compare two measurements to answer a question, or to see a connection between two types of data. For example, comparing the odometer reading of a car to the price of a car can help determine if these factors are related. In this lesson, you will study scatter plots, a new tool for visually representing data as a way to relate two sets of measurements. You'll be asked to analyze the data to see if you can make a prediction or come to any conclusions about the relationship you find. As you work today, use these focus questions to help direct your thoughts and discussions. How can I organize the data? Can I use this data to make a prediction? What does a point represent? And is there a connection between the two variables? So we're going to start with this first question, 7-13. Make sure on your paper that you put 7-13. And now we'll read. So Nate and Rick were discussing cars again. Nate claimed that cars with lower odometer readings were more expensive than cars with higher odometer readings. His evidence was that his car with 23,000 miles on it was worth more than Rick's car that had 31,000 miles on it. To investigate Nate's claim, the boys collected data from several other car advertisements and found the information in the table at the right. Does the information in the table support Nate's claim? That is, do you believe Nate's claim that cars with lower odometer readings cost more money? Now, as you went through this, you probably had a few problems. One of them is that as I look at these odometer readings, they're kind of scattered about. They're not in an easy order, and that makes it so that the prices also aren't in an easy order. It's harder to tell whether or not smaller leads to more money or vice versa. One thing I can easily do is take like a really low one, so just 6,000 miles on it for 50,000, and then jump up to some higher ones like 99, and we see 10 and 13,000. So we did see that the lower odometer reading did in fact cost more than one with a higher odometer reading. How perfect that is still not quite as clear as perhaps we would like it. So let's look into the next problem. So let's look at 714. Melissa looked at the data from 713 and she said, I need to be able to see the data as a picture. She's a visual learner. She needs that picture. I cannot tell if there's a relationship just by looking at a large list of numbers. She decided to use this box plot. Her box plots for odometer reading and price are shown below. So do these help you decide if Nate is correct? Why or why not? Now remember, as we're looking at these, Nate's assumption was that if the odometer reading is higher, then the price will be lower, and vice versa. So, do these pictures help us to confirm that Nate's right, confirm that he's wrong, or do they not help us? Make sure to describe your answers fully. Now, one thing we might notice with these, there isn't really a connection between the two. Even if I'm looking at the this 99, we knew we had some 99s in there, I don't really know where that 99 fits over here. And so I can't really tell if low odometers are high prices or high odometers are low prices. I can't really tell because these two aren't really connected. The box and whisker plot is more to show just single data from a single set. I can see how spread out odometer readings are. I can see how spread out the prices are. But I don't see the relationship between the two. So now let's go to 715. Melissa wondered if a coordinate graph could help determine if there was a relationship in Nate's data from 713. So you guys are going to use the link in Google Classroom. I've created a link for the Student Need tool. Make sure to go to that. And it says first you're going to set up a graph showing the odometer reading on the x-axis and price on the y-axis. Label each of the intervals so that all of the data will fit onto the graph. Plot the data points from 713. So the way we're going to do this, a lot of it's already set up nicely for us. If you come over to the E tool, now over here we're going to have X and Y, and we're going to need to type in the numbers for our data set. Alright, so I'm going to try to open these in two sides of my screen. And then we'll make this full screen again. But first we've got 35 and 38, and you'll notice it automatically started graphing that. Go down to the next, 55, 16, 6, 50. Alright, so go ahead and finish sticking all of those in. Pause this video until you're done with that. Okay, so hopefully you've got a graph that looks just like this. And through this graph, we are seeing a bit of a relationship. Make sure you can also see these dots down here. So let's look back at some of what we should be doing. We've already made our graph. Said describe the scatter plot you just created. What do you notice about how the points are placed on the graph? Are you seeing any patterns? So one thing that I'm noticing as I look at this, there's not a clear pattern. They're not all lining up nicely for us. However, just because I don't see a super clear pattern, that doesn't mean that there's nothing there. So one thing that I am seeing is a bit of a downward trend of these. Okay, all of these seem to be going in this kind of a direction. So I do see this downward sloping to what's happening with this. We do see that the cars are getting lower values the higher up the odometer reading goes. So make sure you've written in your answer for B. Let's look at C. Once again, make sure to write in the answer. Place an additional point on your graph for Nate's car that has an odometer reading of 23,000 miles on it. Explain your strategy for deciding where to put this point. Alright, so we're going to make a point for his car that has an odometer of 23,000 miles. You'll notice that in this chart that we had originally, right up at the top, the odometer readings were for X, and rather than writing out a full 23,000, we just put in 23. So if we look back at our graph, we would need to come over to 23, and we got to figure out where would it fit in best. So I'm just going to go ahead and add in the 23. Over here in my X column, and in my Y column I want to try and figure out approximately where it would go. So just looking at your data, I want you to try to think about where would that dot best go, and it doesn't have to match exactly what I'm thinking. Now I was thinking about 40, and you can see kind of where that went in, and hopefully you can understand kind of why I did that. I feel like it matches a bit of the pattern that I was noticing, this downward trend in this direction. And I felt it kind of fit in there. Yours, of course, could be different. When a relationship exists, one way to help show a trend in the data is to place a line curve. So now we're in D. That in general represents where the data falls. This line is sometimes called a line of best fit. It does not need to touch any of the actual points. Instead, it shows where the data generally falls. The line is a mathematical model of the data. Models of data can help you describe data that more easily helps you to make predictions of other cars and different mileages. With your team, decide where a line of best fit could be placed that would best model the data. Are there any limits to where your line makes sense? So here's what I want you to do. Take a look at your graph that we have. Now, what we would just do is try to draw on that. And this is how we create our lines of best fit. Now, once again, it's not going to go perfectly through every single point, and it doesn't need to. What it needs to do is kind of follow the trend of the data. And you guys can see that I do have this downward sloping. It did go through a few of them, but more than anything, it's going kind of through the center of them. Now, as you kind of have your line of best fit on there, based on the scatter plot, would you agree that Nate's claim that cars with higher odometer readings cost less? Look at your scatter plot and, oh, sorry, we should be in E. Using the line of best fit, can you predict the price of a car with an odometer reading of 80,000 miles? If so, explain how the line of best fit helps. If not, explain why it was not helpful. So I'm going to go ahead and draw on my line of best fit again. Dun, dun, dun. There it is. So now if we go up to 80,000 miles, can now come over here to make my prediction, which would look like about $14,000. I'd expect if something is at 80,000 or, yeah, 80,000 miles, that it would be about worth $14,000. And I can see that my line, even though there weren't any dots around here, the line kind of fills in the blanks about where dots might be were we to put them in, where different values of odometer reading and pricing could be. Alright, so based on the scatter plot, would we agree that Nate's claim that cars with higher odometer readings cost less? You guys should look to your scatter plot to justify your answer there. Make sure to write out a complete description. One thing that I do notice is, yeah, it does. As our odometer readings, our X values were going up, as X goes forward, the dots seem to be going down. So the higher the odometer, the lower the price. Okay, so In this next section, I want you guys to be looking at each of these different scatter plots. Now we want to figure out which scatter plot is going to match one of these. So A might match one, B might match one. So we're going to look at the scatter plots to figure out which statement fits with each scatter plot, decide if there's a relationship between the data. Does it change in a predictable way? And that's where we're talking about when we say there's a relationship. It seems to be changing in a predictable way. If there is a relationship, describe it in a sentence. If there is no relationship, describe why you think there is not one. Alright, so first we've got I. Now we do see it's kind of going up a little bit. So we do see a pattern. So let's see if there's anything that would match this. How fast a dog can run and the length of the dog's fur. Well, I don't know that the fur length is really going to make the dog run any faster. And so I don't know that it's really attached to this first one. So what I might say is that A and this, how fast the dog can run and the dog's fur, they're unrelated. I don't know that I'd see a pattern there. Okay, let's look at the next one. A person's age and their body temperature. Okay, well, I know that body temperature throughout your life should remain at a 96. So I like this one. It doesn't seem like the dots are going up or down. They're just kind of going straight across. So even as the people are getting older, it's not necessarily changing their normal body temperature. Alright, let's look at this. The child's age and the size of their feet. Well, as a child gets older, their feet will get bigger. I do notice here we've got a section where as one is going up, so is the other. So we could say feet and age are both going up together. So I would link those two, which would lead us to say that the outdoor temperature and the percentage of people wearing long sleeve shirts, as it gets hotter, so as our X goes higher, we do seem to see people are wearing, less people would be wearing long sleeves. That number is going down, and that's the pattern we notice in that one. Okay, make sure on your paper you've written in your answers for every single one of the questions. If you need to, grab one of the books so that you can make sure you've answered one of each of the questions. If you finish early, work on Success Maker for the rest of the time.